So one curve is always on the top and the other one is always at the bottom. Integral will do this. Integral, like I told you, it's a CAT scan, if you want to imagine this way. When you go to a doctor and you put your cat, for example, for a scan. So the cat is lying down and then they are scanning first it's going to be integral from A to B. So let's write it down. It will be area between two vertical, I would say two horizontal lines, not lines, curves, will be area from integral from A to B. So the first scan happens, all this rectangle, from A to B is the rectangle. So it's a little bit too much, as you can see. This is going to be the first CAT scan that is trying to figure out the scan of the body of your cat. Then, from A to B, it scanned too much. And this is when we're supposed to tell the CAT scan that actually there are shapes at the top and the bottom, and your scan should scan from the shape. Let me put it in bright yellow. From the top curve to the bottom curve. Then this net will give you a very precise understanding of the area. So that's basically how CAT scan is doing it. Doing it from A to B and then top to bottom. And then if you want to do volume, you also do front and back. And that's how you get volume. Since we're only working in 2D in this class, we only do this type of things first. So how to do CAT scan from top to bottom? You literally put the function at the top, which is f of x, and minus the function at the bottom, which is g of x. Kind of makes sense. And then you integrate this all with respect to whatever you chose. That is an important idea here. If we chose to go from A to B, A and B are located on the x-axis, then x will be at the end. So I will write down, this is on A to B. This should always match. If there's an x at the end of the integral, these guys should be also x stuff. So x is from A to B. This is what we call vertical slicing, because how my functions are located from top to bottom. So we do vertical scanning. Vertical scanning here is more important because it has some shapes going on. Horizontal scanning, looking like this. I'll go back in a second. One function is always, or at least on this interval, from the right, and the other one is always on the left. The one on the right is f of y. Pay attention, it's now x equals f of y. Bless you, that is one on the right. The one on the left is g of y. That one is always on the left. Again, maybe they will switch at some point, but at least on the interval, what kind of interval? Interval on the y-axis from C to D, you have always one function on the right and one function on the left. Now it's not convenient to do up and down anymore. How would you do this up and down if there's like the same function is on the top and on the bottom? The same function is at the top and at the bottom. So this one is convenient to scan from right to left. This is what we call horizontal slicing, because functions are now changing on a horizontal location from right to left. You always go from bigger to smaller one. Top is bigger than smaller and right is bigger than left one. 5 is bigger than 0 no matter where 5 is located with respect to 0, higher or to the right. So horizontal slicing also gives you area. A equals. But now we are choosing to run on the y-axis. So not only dy will be at the end this time, but y is running from C to D. Y is scanning from height to height now. From D goes higher, so it will go from C to D. The rectangle will now look like this. From C to D, it's scanning up, like so. Now it did too much. You see, this is a whole rectangle. And now we tell a CAT scan, well, actually, there's shapes on the left and right. What kind of shapes? And you tell CAT scan, on the right, there was f of y, and on the left, it was g of y. Now, as you can see, again, everything should make sense. integral with respect to y, all functions inside are with respect to y, and limits of integrations are also with respect to y, c and d. All this should match on c and d. So I will call it case 1, case 2. Some books call it type 1, type 2. I like cases. Case 1, case 2, and we're going to practice both. Very creative idea how to find the area of objects. Depends how you see them. Do you see this water bottle as height from bottom to top, or as length from right to left? Some things can be done both ways, and the answer should be the same. And then you as a scientist have to decide which way is easier to calculate, more convenient. So that's kind of the idea here. What do you think about this? Pretty realistic. Imagine how would you explain a computer, how would you code in a computer, how to figure out the area of the leaf you picked up from the forest. The computer will ask you, so how should I calculate the area? From this way or like from this way? That's exactly what we're teaching you. Integration have to be set up correctly. We always go from bigger minus smaller idea. Whatever is on the top is bigger than whatever is on the bottom, whatever is on the right bigger than whatever is on the left, and area should be positive. If you got negative area, probably you messed up. It's still area. So a question for you. A question for you. When we ask you to find the area below the graph, the area below the graph, that's what we did last class. Y equals f of x, and it looked like this. Y equals f of x. That's what we did in class last time. So we asked you to find this area below the graph. I even shaded it for you. We told you a lie, honestly. We said this is the integral from a to b on the x-axis, from a to b, f of x dx. And we said this is how we define integration. Integration is the area below the graph. What do you think now? What is actually this integral should be?
So wait, it's from a to b, not...
It is from a to b.
It's f of x minus 0?
Minus 0, exactly. It is actually f of x minus 0 dx. It is not area below the graph. It's area between two graphs. What kind of graphs? One is y equals f of x, and the other one, like you showed, horizontal, y is 0. So it's not below, it's still between. We're just kind of slowly getting to the topic. I don't really see why. Why not just introduce it right away? This way, but okay. And it's case 1. It's top minus the bottom. So that is a general case. Area below the graph was just one of the cases. And I don't know why we have to rename it later in the literally next chapter. So now you know. Now you know. So find the area between two graphs, between f of x and 0. This is how it works. But now let's do some kind of cool example. Find the area bounded by. Bounded by. So very nice American notation. One of my favorite American notation is BDD. Bounded. BDD is bounded. Very nice. Bounded happens so often in math that it's nice that they created this idea. We don't have this shortcut in Russian. So bounded by, you will see this a lot. In your homework on the test, you will see bounded by, bounded what? So you have to just read what functions are given and start working. I'm going to do one example and then more on Monday. So two functions, 5x minus x squared and 2x. For this chapter, you have to remember how to graph functions. And that's what scares you because you don't remember probably what is cubic function, how does it look like. Sine function is the biggest fear when I ask you to plot sine function correctly. I have video that explains you basic functions we expect you to know. I will send it to you and then review, you'll be fine. So don't be scared too much, yes.
Wait, why do we need to graph them? Don't we already have the formula?
Because we don't know which one is on the top, which one is at the bottom, or maybe they even not like that, maybe left and right. Without the graph, you don't know. That's the case when you actually have to visualize it.
I suppose that in this case it's fairly simple, but in others it might not be. That's
Yeah.
what we're going to try.
Exactly. Sine and e to the x depends on the location. Sometimes one will be on the top, the other one is on the bottom, because sines keep going up and down. Let me call one equation number 1 and the other one is number 2. The first one is quadratic equation and the second one is linear. So, step 1, now I give you steps. Steps. Sketch the graph, as always. Sketch the graph. Sometimes you don't have to be precise. You just need to know the first one is a parabola. What can you tell about that parabola?
Well, it crosses with 0, 0.
That's a good one. What else?
It's a concave down.
Concave down. The moment you see minus in front of the x squared part, it means this is the parabola that looks sad. That means that one probably will be on the top, while this is a line, probably will be at the bottom. Sketch the graph, comma, sign each function. That will help you a lot. I keep forgetting doing that, but if you have 7 functions and you did not sign them right away, you will get confused later. So let's do that. I will help you to sketch, but you have to practice with this to get good at it. So, parabola concave down, 0, 0, but it's kind of shifted to the right, and so on. Whatever. It looks like, since it's at 0, 0, it's something like that. Parabola. Y equals 5x minus x squared. If you have to be precise, or you want to, you can actually find the vertex. The vertex has a formula minus b over 2a. Do you remember what vertex is? This thingy on the top, the middle? So minus b over 2a gives me a vertex 3. So this is 3 from the formula. Minus b is 5, minus 5 over 2a. What is a? Minus 2. So it's not 3. 2.5, I think, yeah. Minus b, okay, let me write that. X squared plus a, x squared plus bx plus c. My a is minus 1, so it's going to be minus 2 at the bottom. B is 5.
Yeah, it would be way easier to find we could just...
Yeah, it's minus 5. It's 5 over 2, right? I think.
We could just find the vertex by
5 over 2.
taking the derivative.
Oh, yeah, that's the other way. Yeah. So,
Probably make it even easier.
now let's do the line. The line, you know how to sketch lines, you guys. X and Y, just plug 2 points. 0 gives you 0, 1 gives you 2. So at 0, 0, at 1, it is 2, something like that. The most important part, it says 3. What happens? No, that's going to be later. So you just draw this and write it down. Y equals 2x. Sign it. This is good. This is actually good enough to finish the problem. Because from this information, you need to find 2 things. You need to decide, actually, are you choosing case number 1 or case number 2? Which one's on the top, at the bottom, which was on the right and on the left? This case can be done both ways. Because as you can see, line is on the right all the time, but it's also at the bottom all the time. We're looking for this area. Bounded by means here. So this is the area that was created. It looks like so. You don't have to indicate it with different color because actually coloring helps here to know which one is where. Choose the case. Usually students choose top and the bottom. Why? We're going to do second case later. For the second case, if you look at the formula, they want us to solve everything for x. For the second case, you need to have x equals, and that's extra step. Since everything is given as y equals, you don't want to solve this for x. So sometimes one of the cases is impossible to do because of that. Since everything was given in terms of y and you don't want to do extra step, case 1 is more practical here. So it's going to be step 2. Step 1, sketch everything and sign. Step 2, choose the case. Choose the case or the type. I'm choosing case 1 and I will put dx over here. Case 1 is top minus the bottom. And dx notation reminds me that everything should be y equals blah blah blah. So it's y equals f of x kind of case.
Yeah.
Right? That's exactly which one we have, so that's a good part of it. What function is on the top? Let's decide. From the graph, you can see, and you can guess, parabola was concave down, so it's kind of a cup looking down. So it's closing the line. Parabola is at the top, do you all agree? Y equals 5x minus x squared is at the top. Which one is at the bottom? Well, only line left. If you have 5 functions, you actually have to figure this out and break into pieces sometimes. Let's write down like this. Y equals 2x is at the bottom. Everything is ready except a and b. The integral will be integral top minus the bottom dx. But we did not find where x is running. x is running from what point to what point? And these points are coming from points of intersection. Step 3, find points of intersection. So, points of intersections. In this case, we just need x's. We don't need both points, x and y. We just need to know this x running from where to where. That means you need to put those functions into the system. 5x minus x squared and 2x. This is a system that gives you points of intersection. Left-hand sides are equal. Right-hand sides should be equal this as well. 2x equals 5x minus x squared. This is what we teach in algebra classes. Move everything to one side. It's a quadratic equation. Don't divide by x. Never do that. It's going to be 5x. Now let's do to the left.
Why don't you just subtract 2x from both sides?
Yeah, that's what I'm doing. X squared, 2x minus 5x is minus 3x equals to 0. Quadratic equation, you can do quadratic formula if you want, but in this case it's easier to factor out. X factored out gives you x times x minus 3 equals to 0. And you have two solutions. X is 0 and x equals 3. That's exactly what we needed. We never needed the vertex. We never needed anything else. We don't even need y coordinates here. Sometimes we do if you choose case 2, but we don't in this case. So it's ready. Build the integral. Step 4. Build the integral. And solve it. So let's see. In the multiple choice question on the exam, we're going to give you several integrals and you have to choose the correct one. Let's build it. Integral from 0 to 3 dx. Inside, everything should match now. All the functions should be in terms of the x. And the proper one should be at the top when the proper one should be at the bottom. If you mess up, your answer will be negative but correct. So you just need to switch it back. If your error is negative, you messed up the order probably. So the function at the top was 5x minus x squared. It should go first. 5x minus x squared minus, and the other function, put parentheses everywhere, was this line. It was at the bottom, dx. Scanning top minus the bottom from a function to a function, but then on the x-axis from 0 to 3. Done. This type of the integral is right now on your quiz. So let's practice right now, very nice. And then you repeat it on the quiz. They're very straightforward. Your job is to be careful. Don't panic, know what to do. First, simplify whatever is inside. 5x minus 2x is just 3x minus x squared dx. This is a definite integral, which means you find antiderivative, and instead of plus c, you put a bar and you plug 3, minus, you plug 0. Antiderivative of 3x is?
3x squared divided by 2.
Amazing. Good job, people. I can see who is doing homework. And then x squared gives you?
X cubed over 3.
X cubed over 3. Ask, maybe like you want to ask right now. How did we get this? It's nice if you ask. Adding 1 power divided by this number. N plus 1 over n plus 1. So 2 becomes 3 and then divide by 3. Instead of plus c, which happens with indefinite integral, you also have this on the quiz today. Both definite and indefinite. Since we see numbers at the limits of integration, we need to put bar 0 and 3. And the idea is you plug the top first. That is the definition of the definite integral. Fundamental theorem of calculus tells me. Plug the top, which gives you 3 times 3 squared over 2 minus 3 cubed over 3. Parentheses. Plug the bottom. But bottom gives you 0, so I'll just write down 0. 0 squared, 0 cubed. Usually people do not write details if it's all 0. That's convenient. Carefully calculate the answer and it gives you 9 over 2, hopefully. See, it's positive. If you got the negative one, check. Maybe you messed up. Maybe you forgot the graph. Because technically speaking, you can build this integral without graphing, but you might mess up who is on the top, who is at the bottom. Maybe there's someone who's on the left and on the right, and so on. But this is the area. What kind of area? Area of this piece bounded by parabola and line.
Wait.
Yes? I'm waiting.
I didn't get 9/2
Yeah, I'm not sure about 1.5. I actually never checked.
because
How much did you guys get?
what I got was 21.5.
Maybe. 9 over 2 times 3 minus 27 over 3, which is 9.
Oops, I made
Yeah.
a mistake.
3 times 9 is 27
Never mind, you're right. It is 9.
minus 2 over 9. Minus 18. No, it's 9. Yeah.
Because, yeah, 27 halves minus 18 halves.
Okay, now you have good notes
I
here.
made a stupid mistake.
Okay, checked. Questions? What do you think? Not too bad. There is, of course, the other case which I need to show you, but I kind of want to move to the quiz and help you a lot with the quiz. So I guess let's do that. That's a better idea. But we will do right and left on Monday, so that will be fun. You will see it's actually pretty creative.